Alright, so here we're going to try a little practice with the trapezoidal rule. We are asked to approximate the integral of e to x squared from 0 to 2 using the trapezoidal with n equals 4. That is 4 approximations using trapezoids. What that curve looks like, e to the x squared, I have it over here. It actually comes out to be a kind of nice parabola of sorts. But what this is asking then is from 0 to 2, approximate, and it goes way up there, it doesn't hit for a while, but approximate the area under this curve, so this area here. Approximate it with the trapezoidal rule. Interestingly, you can think of the trapezoidal rule, so the midpoint approximation, that is you find each of your intervals, so approximate here, but then you approximate at the midpoint of it. So I'd approximate here, so I'd approximate with a rectangle at each of those midpoints. The trapezoid, in one way you can think of it finding the midpoint, finding the average before doing an approximation. Trapezoidal is kind of doing it after, because in a way you are finding the right endpoint approximation, the left endpoint approximation, and then finding the average between those. That's one way to think of it when you're doing the trapezoidal rule. It's sort of the average of the left endpoint and the right endpoint. Alright, back over here, I have our trapezoidal rule. Again, it says the approximation of the integral is the change in x divided by 2 times the function evaluated at the first subinterval plus 2 times the next subinterval, so on, until we get to our last intervals down here. The second to last one is still 2 times it, but the last one was 1 times. So we see this sort of pattern going on of the 1, 2, 2, 1, where it's going to be 1 on the first one, 2, 2, 2, 2, 2, until your last one is back to times 1. So as we find this trapezoidal rule, we want to find what is the x values of each of our subintervals. So again, we are going from 0 to 2, and with n equal to 4. So what is my change in x? Well, change of x is equal to b minus a over n, so 2 minus 0 over 4, which is 2/4, which we should be able to reduce to 1/2. So every 1/2, as I go along the x-axis, every 1/2, I have a new subinterval. So I can say x sub 0 equals 0. So we want to start with the x sub 0, our starting point, our left endpoint. We see here we start with our left endpoint. And we go over x sub 1 would be 1/2, because we're moving over 1/2. Now let's move 1/2 more down the line, and we hit 1. X sub 3 we hit, I'll go with 3/2, or 1 and 1/2. And then x sub 4 is equal to 2. And so x sub 4, our n equal to 4, we should expect to hit the right endpoint then, and we do. So those are our 5 subintervals. So now we can actually start setting up the trapezoidal rule right from there. Alright, so it equals the change in x, which we said is 1/2, and then that divided by 2, so I'll leave it like that for now, times, not x sub 2, but f of x sub 2, our function being e to the x to the square, e x squared. So plugging that in, it's e and then 0 squared plus 2 times e 1/2 squared plus 2 times e 1 squared plus 2 times e 3/2 squared. And notice now this is our last subinterval, so it's back to just 1 times e2 squared. Close off my brackets. It's nice when they ask us only do 4 subintervals, because it can get to be quite lengthy writing out all of these things when you're doing approximations. So 1/2 divided by 2 becomes 1/4. This is still e to the 0th plus 2 times e to the 1/4 plus 2 times e to the 1st that's 2 times e to the 9/4 plus e to the 4th. And at this point, we've actually done pretty much the meat of our approximation, because now you'll just take each of these values and plug it in your calculator. Well, you don't have to the first one. E to the 0, anything to the 0th power is just 1. So it's that. And now I have gone ahead and already plugged these in the calculator. So I'm going to write the decimal approximations of each of these. So we get 2.57, 5.44, 18.98, and e to the 4th is 54.6. Add those all up and you have 1/4 times 82.5836. When I added together, I got a little more precision there. I got 4 decimal points, and that equals 20.646, and that is our trapezoidal rule approximation. So this right here allows me to say that the integral from 0 to 2 of e to the x squared dx is approximately equal to 20.646. So the area under this curve here is approximately 20.646 units squared. So using trapezoidal rule is really not too difficult, because you have this formula, and then once you find your subintervals, it is just plugging each x value of those subintervals into your function, being e to the x squared. And there you have it, our approximation.